All right, so last two here, we're converting BTUs. We're trying to figure out how much Fahrenheit the water will change in temperature if you have 1 metric ton and you put 110,000 BTUs in it. So the first thing you want to do here is convert those BTUs to joules. So if we have 110,000 BTUs, we're going to need to turn that to joules. So we need to go from BTUs to joules, and it turns out that it's 1,055 joules for every BTU. So that'll get us to the joules. That should have been red, but I'm sure you're okay with that. There we go. All right. So BTUs is gone. That gives us joules. So we just multiply 1055 times 110,000. That gives us 116050. Should be blue. 116050. All right, so that's how many joules we have. We got to figure out how many grams a metric ton is. So to do that, we just Google that, I'm pretty sure. I don't know that you need to know that. So gram, ton to gram, metric ton to grams. There it is. And it is 1 metric ton is 1,000,000 grams. Okay. So we are using the specific heat is 4.18 joules per grams degrees Celsius. So we have our joules as 16, that thing, 116050. That's how many joules we have. Our grams is 1,000,000, is what we just figured out. So the grams we can put on the bottom. We'll do it in this color. So 1,000,000. And then we're looking for Fahrenheit. So we'll find degrees Celsius first, and then we'll convert that to Fahrenheit. So let's put degrees Celsius is what we're going to figure out. So this will be equal to each other. So if you put this in scientific notation real quick, because that's a nice way to do this, actually, this number on the bottom is 10 to the 6th, and this number on the top is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.16 times 10 to the 9th. And 10 to the 6th, 10 to the 9th, that crosses out. That becomes 10 to the 3rd. So it's this times 10 to the 3rd, which would be 1, 2, 3. So 4.18 is equal to 116. What did I say? 10 to the 3rd. So 1, 2, 3. 1160.5. And then you're trying to find this. So that's divided by degrees Celsius. So we got to multiply degrees Celsius there and divide that by that. So the degrees Celsius is equal to the 1160.5 divided by 4.18. That should be your degrees Celsius, I believe. You will let me know if I did any of that wrong, I'm sure. 1160.5 divided by 4.18. And that gives us 277.6. Oops, why that's an eraser, I don't know. So our degrees Celsius is 277.6 degrees Celsius. And then you got to convert that to Fahrenheit, which is no short task. Maybe it's easier to do Kelvin to Fahrenheit. All right, or Fahrenheit to Kelvin, I guess. How about Fahrenheit to Kelvin? 32 Fahrenheit. So it's the Fahrenheit minus 32 times. All right. So Celsius is that, so that's the same as Kelvin. So to go from Kelvin, so anyway, you could just as easily do this online, but it's the number we got is 277.6. We're going to subtract 273, oops, and then multiply that by 9/5 and add 32 plus 9 times 9/5 plus 32. And that'll give it to you. So if our Kelvin is 277.6, our Fahrenheit becomes 40. Wait, that's not true. God bless it. See, since this is a change, the reason this is causing me so much trouble is it's the change. So it's the difference between one thing and another. So you're going from, for example, uh, 0 Celsius, and which is 32 Fahrenheit. So you're going from 32 Fahrenheit, and then you're going up to 277. So the stupid, I haven't figured this out yet. This is 531.7. So you're going up to 531.7 degrees Fahrenheit. So this isn't trivial by any, and I haven't really quite wrapped my head around it yet, but it's 531.7 minus 32. So your difference in temperature is about 500 degrees Fahrenheit. So equals about 500 degrees. Whoops, 500 degrees Fahrenheit is how much that would do it. All right. I know that's not helpful, but I will figure it out here in a second and just text you an answer for that one. All right. How many kilojoules is a 75 watt bulb? So what we need to know is watts. What the unit of measure of a watt is, and a watt is kilojoules per second. There you go. So a watt equals a kilojoule per second. So therefore, if you did 25 minutes, we just have to multiply this by how many minutes, how many seconds, and we'll get kilojoules, if that makes sense. So we have 75 kilojoules per second, because that's what a watt is. So we need to multiply that by how many seconds are in 25 minutes to figure out the kilojoules. So we know there are 60 seconds in a minute, right? So 25 times 60 will tell us how many seconds there are. So 25 times 60 times 60 is 1500. So that's 1500 seconds in 25 minutes. And so 1500 times 75 is your answer. Now, the way you really should have done this, and there's only two significant figures, so the answer comes out to be 112,500, but then that would be 110,000 kilojoules. All right, so what you should have done though, if not should have, but if you wanted a more hold your hand kind of way, is you start with 25 minutes, and then you convert minutes to seconds, and then you convert, then you use that other conversion there, which is that. Actually, I'll stay here. Oh no. I was so close. All right. So I'm trying to go from seconds to kilojoules. So that's why I'm going to use, I know. See, you kind of miss me and you kind of don't, right? The kilojoules, because I'm playing this stupid game. All right. So you got to go from seconds to kilojoules, and a watt means that there are 75 kilojoules for every 1 second. So that's what that's going to be. And you know there are 60 seconds in 1 minute. And that is how we got our answer. So it's 25 times 60, which is this, and then that times 75. So that's how you would have done it. You start with the thing by itself. And since watt is kilojoules per second, you would use that later as a conversion to get from seconds to kilojoules. Hope that makes sense. I will figure out that other thing so that you don't have to worry about that anymore. All right. Good work. Don't save. I should have saved. How do I turn this off? I need to turn this off. Oh, it was never running. Nope, it was.